My name is Ivo Heinecke. I work for NetUse as a security specialist working with Graylog.
And my name is Friedrich. I'm a Graylog solution engineer, and I'm very curious to see and understand what Graylog did to protect their customers by the magic of DNS.
Great. Then let me explain to you just a very, very brief overview of DNS. We do have clients with their devices doing DNS queries to a central DNS server within the environment of the customer. Those clients do request this DNS server for all kinds of DNS queries. Those could be internal ones, those could be ones to public domains. This DNS server then uses cloud resources in the internet to resolve those queries. Just a very brief simplification and overview.
Ivo, the scenario that you're describing, having internal devices sending DNS requests to an internal server who is requesting to an external cloud server, is absolutely common. So where does cybersecurity come into the game here in that situation?
Cybersecurity comes into play when we have a look at the cloud service. The cloud service in this case is Cisco Umbrella. Cisco Umbrella is a service by Cisco, as the name says. It resolves domains to IP addresses if those are thought to be fine. If they are malicious, Umbrella will resolve it to bogus IP addresses and doesn't allow the client to access their target.
That sounds very interesting. So protection comes by blocking.
Yes.
So for me, that looks like a preventive measure. And that is everything you did for protecting your customer?
No. We do have a big challenge in this scenario. We do have clients, we do have our internal DNS server, and we do have a firewall. This firewall does network address translation for the DNS queries from our internal DNS server. This means Umbrella will not be able to distinguish all the different clients we have on the side of the customer. This is a big problem because Umbrella won't be able to tell us which client did the request.
So that means that Umbrella will provide you with alerts all containing the same sending IP address because these are hidden by the network address translation?
Yes. This is a big problem. And we were able to get this solved with Graylog and with a little bit of scripting and APIs.
Sounds interesting. Go ahead, Ivo.
Yes. So, first thing we did collect the logs from this DNS server into Graylog. Graylog collects all those logs from this DNS server. Those logs do contain a timestamp when the query was done by the client. It does contain a client IP, who did the request. It might contain some reverse DNS on those IP to identify the client with the host name. It does contain the type of query, and it does contain the domain which was requested. This is our Graylog collecting this first very, very important part of our information. And then we developed a little script. This script, in the first step, asks Cisco Umbrella for malicious domains. Those malicious domains are then the ones we want to find. Those domains have been requested by some internal systems, and we need to find out who it is. So, in the second step, we do issue another query into Graylog to ask the Graylog who did those requests. In the third step, this script will ingest new logs into the Graylog, which will contain all the information we need. It will contain the information about the client who did the request. It will contain the type of request. It will contain why Umbrella thought this domain to be malicious, and of course, it will contain the domain which was malicious.
That sounds interesting. So that script helps you to collect all information you need to have an assignment of who is a client who did the malicious request from the internal network, and the additional information from the Cisco Umbrella service that identifies a domain as malicious and also give additional context. Is that accurate?
Yes, it will gather additional context if available. So, for example, if we do have reverse DNS configured on the logs from the DNS in the Graylog, then we know the host name. It will gather them and also ingest them into Graylog again, that we can see the host names of the systems doing those requests.
What type of analytics are you finally doing with the information you collected so far?
We do have different dashboards to see and to understand what is happening. So the first dashboard gives us an overview of all the clients doing requests. So we have an idea if a client is doing a lot of requests to a lot of different domains, or we do see if a lot of clients and if a lot of domains will be accessed by the same client. This is the first thing we see. The second thing we see is a list of domains we see which were blocked by Umbrella. If something is popping up there on a very high scale, it might be false positive and people might not be able to use this service because of a false positive. So we need to check that on a regular basis. And then we are able to unblock it to prevent people from not being able to work.
Wow, that sounds like a really professional approach to the DNS security. From my perspective, it would be interesting to get a bit more into the details. Thank you, Ivo, for explaining the high-level use case. And now let's dive a bit deeper.
Let us have a look at the logs of Cisco Umbrella combined with DNS Graylog in detail. This log was flagged as malware, as this field shows. Here we do see the domain in question, which was flagged as malicious by Umbrella and which was requested by a client. The client we can see down here with its IP address and also its internal domain if available in the corresponding field. In the network DNS resolved IP field, we do see the DNS resolution for the domain which has been done by Umbrella. We do see two timestamps in this field. The timestamp, which is only called timestamp, is the timestamp of the DNS query log from the client when it did its DNS query. The Umbrella timestamp shows the first appearance of this domain in our Umbrella analysis. And since then, we know this domain seems to be malicious. What kind of details can we get out of those logs? First of all, we want to know the IOCs. Here we do have a list of IOCs seen by Cisco Umbrella. We do see the number of requests for each of those IOCs. And we also do see the number of clients requesting those IOCs. If there's a high number of clients, it's potentially a false positive because the domain could be accessed by a lot of clients, but only being blocked by Umbrella. Those clients then would have a problem of not being able to work properly. So we need to know if a domain has a very high number of clients. In the second widget, we do see the development over time for different clients over 5 days to estimate if this is a client which has been active for quite some time, or if this is a new development for a new client having malicious activity or at least malicious requests. This dashboard allows us to identify clients, to hunt them down, and to see what's going on in the world of Umbrella and how effective Cisco Umbrella is blocking stuff from clients. In the last widget, we do see a heat map. This heat map is a little bit complicated to understand, so I will try to explain it in detail. On the x-axis, we do see different domains blocked by Cisco Umbrella for different clients on the y-axis. Those different clients could be IPv4 addresses or also could be IPv6 addresses, as our script is capable of working with both of them. If we do see a horizontal bar in our findings, as we do see here at the bottom, we do know that one client requested multiple domains which have been found as malicious for Umbrella. This could be a sign of a compromise when this client tries to access different IOCs and different malicious sites. If we see in horizontal bar or multiple horizontal findings for the same domain but for multiple clients, it shows us that a lot of clients want to access this domain, but they're not able to as Cisco Umbrella blocks them. This could be a sign of a big lateral movement which already spread it, or it could be a sign of a false positive block, as a lot of clients try to access the same stuff which was blocked by Cisco Umbrella. The color indicates how often those queries happened. In this dashboard, we do see 90 or a little bit more than 90 hits for a single field here, this single IP with this single domain. If the fields are white, it means this number is 0. So, Friedrich, how do I collect those logs from DNS?
Yeah, that can be a real challenge. In our example, we are talking about collecting DNS query logs from Windows servers. The first challenge is to make sure that Graylog can configure a Windows server to collect DNS logs from. In general, to manage log collection on Windows servers, the first component you need is a Graylog sidecar. The sidecar collection logic contains of two components. One of them is a sidecar binary, and the second one is the sidecar YAML file. The sidecar YAML file contains all information that is required to ensure the right communication between the sidecar, so the Windows server, and the Graylog installation that you have.
So, if I understand you right, the sidecar is talking to the Graylog.
Right. So the sidecar YAML contains, amongst others, the Graylog URL, but also an API key to authenticate itself and to prove that it is permitted to request and to receive a configuration for its collectors. Well, so the sidecar will connect with Graylog, and based on the information that the sidecar delivers, for example, specific tags like DNS for a DNS server, Graylog will decide what type of configuration to share with that Windows DNS server. And that is very interesting. So in our case, we configured or we created an Xlog configuration that will make sure that an Xlog will, first of all, collect the right logs on the server and then send it to the right port on the Graylog server. This Xlog config file will be delivered to the sidecar, and the sidecar will analyze its content. Why? Because I mentioned the tags that you put into the sidecar config. So the sidecar will only use the parts of the Xlog config that are relevant for itself based on the tags that you configured in the sidecar YAML. The result of all this will be an Xlog config file that will be understood by the Xlog collector. And this is where an Xlog starts running. So the Graylog sidecar has the permission to start an Xlog instances based on what was configured in Graylog. Once the Xlog config is applied, Xlog will start sending these logs into Graylog. And that's all, actually. That's where all the Xlog logs come into Graylog and where you can see them. Next step is obviously to parse those logs And we will share a parser with you that will allow you to get the domain name out of those logs. And then analytics start.
Where does the sidecar connects to the Graylog? Where does the sidecar connects to which component of the Graylog?
Sidecar will talk to the Graylog API.
And where does the NX log talk to?
NX log talks to the Graylog input and delivers log to that input.
So this connection here is a very low bandwidth, but very sensitive connection because configuration is coming over the connection. This connection has a higher bandwidth?
Absolutely. So usually we see Graylog instances secured with TLS, and the sidecar will run with transport encryption for the authentication as well as the configs, as you said. And if we talk about internal environments, an XLog will usually just send the logs clear text over the Gauss protocol into Graylog.
Is it possible to use TLS here as well?
Yes, it is possible, but in most cases, there is no value in it if we talk about internal environments. If you send them over the internet, it could be relevant, or if you are sending logs from a DMZ to your internal network, it might be relevant. In many cases, it's better to use the Graylog forwarder for those edge cases, but in our example, we just send them without any encryption.
Great. Then, could you please help us to get a little bit more details of those sidecar and the NXLog config?
We'll be happy, and as we said, we will share all the configs in our GitHub repository. To configure log collection, everything starts with the Graylog sidecar. The Graylog sidecar is configured on the log source. So in our example, it is a Windows server, and we do it using our sidecar YAML file that is stored next to the sidecar binary on the Windows server. We have a few configuration items. Of course, we need to configure the URL to find Graylog SIM. We need a server API token to authenticate at Graylog SIM. And then we have a few other configuration items that we don't want to get into details right now. However, there is one very important and interesting configuration capability, and that is tags. Tags try to characterize or to represent what this server does. In the first step, we say this is a Windows server that allows us to have some basic configurations on what logs we want to collect. For example, Windows security logs, because this will be true for any Windows system. Then we have another tag, which is DC. That means this is a domain controller, and maybe we are interested in getting data related to domain controller application. Then we have another tag, which is DNS. This DNS tag expresses that this domain controller is also a DNS server. We could add as many tags as we want. For example, I could also add an app blocker tag, so allowing us to configure a collector config with this app blocker tag, and we will get back to this later in this presentation. The takeaway of this, we can configure the sidecar with tags characterizing what this server does. Based on this, the sidecar will pull the corresponding configurations from Graylog SIM. After looking into the Graylog sidecar configuration, let's try to understand how the collector configurations work. The sidecar is installed on the log source, the Windows server, and with the sidecar is also a WinLog bead as well as a filebeat exe, which are the collectors. And these are installed with a sidecar on the Windows server. The collectors need a configuration file that will tell the collector what logs to collect. And in our case, with that Windows server, we have winlogbeat configurations here. And let's have a look into these. This winlogbeat configuration tells us, will tell the winlogbeat collector on the Windows server what to do. And we have a few things that I want to demonstrate here. So this is the detail of the collection advice that we gave. And the first thing is we want to collect security logs in general. And then we have the next line that this is a conditional collection advice. So whatever happens between this if and that if is under the condition that the sidecar has a specific tag. That's why we have sidecar tags. And then this would be a specific tag that was written into the sidecar YAML. How can we just keep it in mind? So we have that documentation here on the right side. So this is exactly what I did in that sidecar configuration. So this one is depending of the configuration in the sidecar that I demonstrated a second ago. This is about winlogbeat, and we will look into this configuration just in a second. The second, the configuration assignment tag. So that is the tag that will decide whether or not the configuration below will be pulled by the Windows server. It's just the Windows tag because this one is true for any Windows server. Then we have a second configuration, which would be based on filebeat. And this filebeat configuration will make sure that you can get the DNS data. DNS data from Windows Server can be pulled with filebeat from the DNS debug log. However, this is not best practice because Microsoft does not recommend doing it. And in case someone is doing it and opening a support ticket at Microsoft, there may be discussions on whether or not they can help with the debug log used in production. So what we did here is we used an alpha feature from filebeat, and we are not looking for a specific file, like, for example, a DISM log, but we have this ETW file type, which has been created by Microsoft to allow the collection of high volume data. And with that, the analytical logs from Windows Server will be collected. Now let us see what happened on this Windows Server after we configured the collector configs in Graylog. We will find all this relevant data in the sidecar folder. So let's open it right now. And in the sidecar folder, you see we have the winlogbeat binary, we have the filebeat binary, with the Graylog sidecar binary, and here we have additional data. Especially important is this folder because it contains all the collector config for filebeat and winlogbeat and an xlog if you have installed. And here you will see the winlogbeat config. Let's look into it. It looks pretty slim, right? We see there is a Windows tag, and we see that only the security log is being applied. So this server will use winlogbeat to send the security logs to Graylog, nothing else. However, if you remember, we had additional data in the winlogbeat config on Graylog, right? There was more. And I will show you in a second how we can activate the additional log collection configuration. Before we do this, let's just check for the other configuration that we can see here, which is file beat configuration to collect the DNS data. For collecting DNS logs, we use the ETW provider, which is the best practice recommended by the vendor Microsoft. So this server does exactly what we want. However, it would be interesting to get an additional bunch of logs. And I mentioned earlier in the example in Graylog that it could be that we do also collect AppLocker logs. So let's now get to the sidecar and open the sidecar YAML. And we just add another tag. So we have the Windows tag that allows us to collect Windows logs. We have the DNS tag that is making sure we get the DNS collection config from FileBleed. And now we will activate the AppLocker tag. So from this moment, the Graylog sidecar will activate the AppLocker tag. So we save this and we restart the Graylog sidecar. And now let us review the WinLogBeat config. And what happened is that the fact that we have an additional tag caused the Graylog sidecar to download additional sections from the config that we added to SIM. And based on this config, WinLogBeat will download the logs from additional log sources on this server. This is a strong feature, and this gives you a lot of flexibility. And I just wanted to show you how this would be working to understand how we get any data, whether WinLogBeat data or DNS data via FileBeat or via an Xlog into SIM, that will allow us to compare the DNS data or whatever data to the Umbrella log. To make sure there are no open questions, I want just to show you how the same process that I showed with FileBeat works with an Xlog Enterprise as well. Just make sure that you have an Xlog Enterprise available, because the Xlog Community Edition will not be able to work with the input module for ETW. So we have that an Xlog config here. The most important part is that we have this input ETW that will allow us to get all logs from the Microsoft Windows DNS server provider, and that we will write this to JSON. That is, I would say that is it. And then you send it out via Gelf into Graylog. So it is more or less the same logic that we have for FileBeat. It's just for an Xlog. And we will share all of those configurations in GitHub, just to make sure you have both available. And if you want to assign an Xlog, you just add DNS here. If you prefer doing it with FileBeat, you remove it from here and add it to FileBeat. Once we have the logs into system, we need to bring these logs in a format that we can work with. So let's look how this functions. We start creating a pipeline. You see system pipeline, then you are here. You create your own pipeline for doing it. And we kept this pretty simple. So you can understand what we did, really to have things not complicated. We'll show you how we deal with the logs that I get from WinLogBeat. So we set a few fields that help us to identify those logs later on. And we renamed the few fields that are most interesting for us, especially with regards to what will be the query request, because the query request contains the data that we really want to see. This is the data that we will compare to the data that comes out of Cisco Umbrella. So these Cisco Umbrella messages that tell us, okay, we had a query to a malicious site. This one will be compared to what we have in the query request. We do the very same thing for an Xlog. So we simply go through it and we rename the QName field to query request, and we have the results that we wanted to have. So we have the comparable data. What we did for saving storage is we changed the message field. It is really a long field, and it would eat up a lot of database space that we don't really need. So we just added our own string with just a few letters. And that's pretty much it. So these are our rules. We have that pipeline. We connected the pipeline to the default stream where our DNS logs arrived. And now let's look how this finally looks like. Let's see whether we had a few. Yeah, we had a few in our example here. These are DNS logs collected by FileBeat. However, could also be by WinLog, by an Xlog. I will show you in a second. But the most important point is here we see the query request field, and this is the one that we will later on compare to the Cisco Umbrella logs that will allow us to cover the use case that Ivo described before. Now let's just see how this looks for an Xlog, and we will say. And with an Xlog, it's the very same thing. It is not, because I didn't spend so much effort on the parser pipeline. So we have all this still in place, but we have our query request field, which is exactly what we wanted to expect. So you are free to use the collector you want. You don't have to keep all those fields because most probably you don't need them. And you can choose the collector you want. You can keep all the fields you need and just drop the fields you don't need. And then from here, you can go and do the analytics that Ivo shows in his dashboard and alerts.
Friedrich, thank you very much for the explanation of the sidecar. This was very helpful.
Always happy to help, Ivo. However, when I thought this use case through, I wondered whether the information regarding malicious IPs or domain coming from Umbrella is the single source for this kind of information, or whether you have additional sources that help you identify malicious requests.
We do have, in fact, a lot of more other sources of indicators of compromise, as we call them, short IOC. Those IOCs could be domain names from DNS servers. Those IOCs could be IP addresses from network environment, from network infrastructure, or those could be hashes from whatever source you could have. So those IOCs are available commercially. You can buy them from companies who maintain them, who have responsibility for the quality. And you could also use open source threat intelligence from the internet, from GitHub, from other sources. Different certs publish them and use them.
Wow, that sounds interesting. So it means that you can consume threat intelligence or IOC feeds that are publicly available from authorities like a cert?
Yes, you can. You need a little bit of scripting, though. With Graylog, you have the possibility to do queries, to do enrichment. We call it enrichment, within the stream of your data with pipelines. This enrichment happens, when this enrichment happens, you want to check if your logs matches one of those IOCs. For this, we did write a little script. It's called IOC lookup. And this IOC lookup is queried by Graylog for all the different things we have, for domains, for IP addresses, for hashes. And this IOC lookup in the background grabs all those feeds and presents a unified experience for the Graylog for all those different topics we do have.
So where or how does it work? So you have this IOC lookup script.
Mm-hmm.
The lookup script is querying public APIs.
Yes.
And then the lookup script takes the information back and is writing it into a CSV-like list, correct?
Correct.
And that list is like queried by Graylog using a data adapter for CSV files, correct?
No.
Wow. Go ahead.
So what we do have, this script has two parts. The first part is to update all those lists. We have different files for different kinds of IOCs. We do have a file for domains. We do have a file for hashes. We do have a file for IP addresses. And then those files, this is the first part, those files are maintained and updated by the script with a cron job running every now and then to make sure those files are up to date with the latest IOCs. And we do mention in those CSV files where this threat intelligence came from. So we know the source. The second part of the script is a little Python server. This Python server will have requests from the Graylog via an HTTP adapter to make the Graylog query this little script to ask it if this thing is known, if this domain is known, if this IP address is known. If this IP address is known, the IOC lookup will return that it's known and also will return from which source of threat intelligence this IOC is coming from.
So it means that whenever a log comes in containing a domain name, an IP address, or a file hash, Graylog is automatically querying that list. And if there is a match, then it will add the relevant data to the log. So if, for example, there is a DNS request with a known malicious, there is a DNS request with a domain, then Graylog will look up whether or not that domain is contained in one of those IOC lists. And if so, it will add that information, whatever context will be available through the IOC list, but it will add it to the log and make it available for further analytics. Is that correct?
That is correct. We do have dashboards allowing us to have a look at those logs which have been flagged as malicious from the IOC lookup. There are some challenges, though, if you have a look at those logs. For example, somebody is scanning you from the internet. Some random guy thinks it's very nice to run Nmap against your firewall infrastructure. This guy is known on one of those IOC lists. Your firewall will log a lot of drops from that guy scanning your firewall. Those logs usually are very much not interesting, so you don't want to have a look at them. It will blow up your statistics. You could have multiple thousands or multiple 100,000 of logs showing you somebody is doing something from the internet with you. But if the stuff is dropped by a firewall, well, it's not so interesting anymore. So we need to filter that out, but that's very easy with the Graylog query language.
That is perfect. I mean, I think that is a very good combination with what you gained from Cisco Umbrella. And I understand that the analytics that you can do based on all that information is really great to give your customers an overview about their attack surface, about their exposition, about potentially interested parties in, like, I would say, joining or perpetrating their infrastructure. And that helps me understand how you actually help your customers being protected via the magic of DNS.
Yes. And we don't just help our customers, because today we will publish this script for the enrichment with Umbrella logs and also this IOC lookup on GitHub. So it will be available for free for everybody using Graylog and having fun with it.
Thank you, Ivo.
You're welcome. Thank you very much, Friedrich.